Hello everyone. So we will continue from the last video. So what I said is, if I write the button reading here, okay, if I write the button reading here, what will happen? We will read the button one time and we will keep iterating. So if the user is pressing the button during the first or second or third iteration, we are not able to read the button because that already happened in the line number 10. So during this time, the user is not pressed the button. Let's say he didn't press it. So for loop will start and it will keep working. So even the first iteration, second iteration, let's say during the third iteration, user has pressed the button, but we don't go to this line to read it again. Okay, we are looping inside the for loop, so we are not able to break it. You get it? So button reading also should happen during each and every iteration. Then only we will know, okay, the button is pressed. You get it? Okay, right. So where we should have the button reading is that also should be inside the for loop. So I'm not explaining like earlier very slowly. I didn't do it very slowly because we have come a little far now, more than 150 tutorials in the Arduino, so we could go a little far, I guess. Okay, so here only we have to do the button reading. That means during every iteration we read the button first. If we found it, we break the loop, otherwise we will proceed. Okay, very simple, right? Nice. That's okay. So okay, so what we are going to do is, okay guys, what we are going to do is we are going to read the button here. So how do you read the button? Okay, button press, I said you that comes under digital input. Okay, digital input. So how do you write a digital input? You have to say digital read. We have studied it a lot. Okay, and a particular pin. Let's say your button is connected to pin number 2, so we are going to digital read pin number 2. Okay, and I'm going to have int, okay, x is equal to digital read 2. You know all these things, guys. Okay, we have studied it enough. Okay, then what I will do, I will check whether the button is high or low. So if I am using this input pull up, what will be the x value when the button is pressed? If we are using input pull up, when the button is pressed, x is 0. Okay, if we are using input pull down, if the button is pressed, x is 1. Okay, that is how the circuit is going to be. You know that, right? So I'm going to use input pull up as usual because we have an internal resistor for that, so that we can go for the input pull up. You know that, right? We have studied it enough. Otherwise you have to watch the videos in the digital input and come back here. Okay, that's nice. So now the problem is I'm going to use input pull up, and in the input pull up, when we press the button, it is 0, otherwise x is 1. Okay, so we have to check here whether the button is pressed or not, right? If the button is pressed is true, we have to break. Okay, so I will write if x is equal to 0, that means button is pressed. That's true. If this is true, break it. Okay, else means what? We don't need to write an else part, because if this is not true, we will not get into the if condition and we will proceed with this. So we don't actually need a else part. You get it, right? Let's say button is not pressed, that means x is equal to 1, so this is false. So we don't get into the if condition. Okay, we'll skip everything and we'll go to the next line. So in the next line we have this scenario. So we will switch on the LED. In case if x is equal to 0, then we will break and we will skip the for loop, the rest of the for loop. Okay, the for loop itself will break and it will go to the line number 19. Okay, is this code clear to you guys? Okay, we are not done with the code yet. Okay, so this is fine. Int x digital read 2. So when we are doing a digital read pin, we have to again set the pin mode for this, right? So where do we set the pin mode for what? For a digital read input pull up, because I'm going to use input pull up. Okay, so we do it inside the void setup. Okay, so I will write an enter after this LED pin mode, and I will write it, or we can write before that. Okay, so let's write it first before everything else, or we will write it after the variable declaration. That makes sense to me. Okay, so we are good with the int I. So what I will do is I will say pin mode. Okay, see this pin number 2, right? I'm going to read pin number 2. So we have studied it enough, right? That's why I'm telling it very fast, in a fast manner. Input dash pull up. So you know all these things, guys, right? So we are saying pin mode input pull up means we will get the Arduino will take the internal circuit of the input pull up, and it will give the particular pin and 2 and say Okay, connect the button. Okay, and you have to connect the other side of the button to ground, so that when you press the button, if I am correct, yes, when you press the button, it should go to 0. Okay, so I have taught enough in this series on the input pull up and digital input series. You have to go and watch it if you don't understand this. Otherwise, you will not understand this. Because if I go to explain this will not end for now. Okay, so you know this. Okay, so we are good with the void setup thing now. Okay, so then we have declared the value I value for this thing, and the only thing is we have added this input pull up thing. All good, right? Fine. Then we are reading this digital read value for each and every for loop iteration, and if we find the button is pressed, we quickly break the for loop. And we come out of here, obviously all the LEDs will go off after that, and forget about this 500 millisecond delay, we don't care. Yeah, we do care, but it's okay. Okay, let it be off for a while, and it will start from the beginning. So it's a kind of reset. No matter, let's say it's the 4th pin, if you press it, it will start from the beginning, because it will break it and switch off everything and start from the beginning. So for the user, what he will feel is even if he has 100 LEDs, let's say the LED switch on is now at the 50th LED or 60th LED. If the user is press the button, the loop will break and every LED will go off, and maybe a small time delay, and again it will start from the initial LED. So he will feel wherever the LED blink is, if I press the button, it will start from the first LED again. So it's a kind of reset. Do you understand this, guys? I hope you understood this, right? So that is fine, but there may be a small issue here we could find, but I hope that will not be a big thing, because let's say during an iteration, okay, this program is switched on an LED and it is in the delay time. That means 400 milliseconds. It's a very small delay time, but still it's in the delay time. In that time, if the user is pressing this button, we are not able to read it, because delay means Arduino will stuck everything and stay calm for the particular time. So that's the purpose of delays. Okay, so this is a disadvantage of this usage of the delay. And also, when the user is pressing the button, if this delay is happening here, okay, if this delay is occurring here, anyway we are not reading it here, so we don't have to worry. Okay, so we will ignore it. Only the light is LED is lightning when the user pressed, it will start from the beginning. When this is already off at this delay, user doesn't have to worry, because even whether he is pressing it or not, anyway this loop will end and the void loop will start it from the beginning, first LED. Okay, so that will not be a problem. The problem is arising only during this flow of these LEDs. They are only when they are running. So that's why we are reading this here. So only the thing is, this delay may affect it. But what we can say is, this delay is very small. It is less than a second. Okay, 400 milliseconds. So we will assume when the user is pressing the button, it will be the button pressing time, that pressing duration will be more than 400 milliseconds. If that is more than 400 milliseconds, then obviously that will be caught under the digital reading, because to run from this to this, there will be taking almost 0 time. In no time Arduino will run within this. Only here it will take time. Okay, so if the delay is slightly more, if the button pressing duration is slightly more than the delay, then obviously it will be caught here and this will be broken. Okay, you understand? If I have a 5000 milliseconds, that means 5-second delay here, then there is a lot of chance, if you are pressing the button during this 5000 delay time, Arduino will not break the loop. It will keep continuing it. Why? Because we are not able to read it during this delay time. We are stuck here, we cannot move anywhere else. Okay, so that is a disadvantage of using delays. There are other options. Okay, we can use this scenario without a delay, without using a delay. We can do it. Okay, we will see that later. So for the moment, since we have a small delay, we don't have to worry. Okay, so I hope you have understood the flow very well now. So in the next video, we will do a demo and see whether it really works or not, guys. Stay safe.